Hello everyone. In this lecture of the Essential Calculus problem series, we will solve this integral, the integral of cosine cube x times sine x dx. And we will use here the substitution method. How we will use it? If the derivative of a function is multiplied by dx in an integral, such as if we have a function u and if its derivative is multiplied by dx, we can use substitution. Here it doesn't matter how u appears, whether it may be raised to a power as u square, u cube, or u to the power of 5, or it may be inside a square, that's it may be square root of u or cube root of u or etc. And it also may be in the denominator of a rational expression such as 1 over u or 1 over u square, 1 over u cube, or etc. What truly matters is that the derivative of that function u prime is multiplied by dx. This tells us that we can use here the substitution method. Our integral was the integral of cosine cube x times sine x dx. And since the derivative of cosine x is minus sine x, we can use here substitution. Let cosine x be u, then minus sine x times dx is du. This means that sine x times dx is minus du. Here we rewrite cosine x as u and we rewrite sine x dx as minus du, and the integral becomes minus, I will take the minus sign outside of the integral, and minus u cube times du. And here we know that the integral of a function x to the n is we add 1 to the exponent x to the n plus 1, and we divide it by the exponent again. Now, since we have here minus u cube, its integral will be, we will add 1 to the exponent and we will divide by exponent again. Then the integral becomes 1 over 4 times u to the power of 4. But here we have cosine x is u, then we will say that cosine to the power of 4x and plus c. We add a constant because the integral was an indefinite integral, so the answer is this. And in the next problem, we will solve this, the integral of cosine cube x plus cosine square of x sine x dx. See you in the next video.